Hey, welcome to your first lesson. We're going to do two sections out of chapter 1 and then continue with chapter 2 and put them all together. This section, 1.7, is linear inequalities. You've done this in Algebra 1. Math 22 is a lot of Algebra 2 mostly, and a little bit of pre-calc. Pre-calc is a lot of Algebra 2. So you're going to see things over and over again as you go through your math courses. This one, inequalities, it's where you just don't have one answer. Inequalities are used to order real numbers. They can be solved for a variable by finding all values of a variable for which the inequality is true. These values are solutions that satisfy the inequality. And when we say satisfy the inequality, we're meaning it makes the inequality work. It works, it's true. So using a number line, it shows the graph of the inequality here. So if I were to have an answer of x is greater than 1, well, you're not equal to 1. So, probably in high school what you did is it was an open circle and you shaded to the right because you're greater than it. So any of these numbers satisfies or makes this inequality true. So is 5 an answer? Yes. Is -2 an answer? No, it does not satisfy. It does not make it true. So you were used to writing x is greater than 1. A more mature or sophisticated math notation would be saying, if you're greater than 1, you're 1, 2, 3, 4, 5, 6, 100, 300, all the way to infinity. So you could write that as an interval and you'd say, you are from 1 all the way up to infinity. And you'd put a bracket because you actually touch 1, but you don't actually touch infinity, so it's a parentheses. So you could write it like that, or you could write it like that. Now, I don't have a preference, but if you're taking a test or a quiz and you have multiple choice answers and you see this, you need to know that this means this, okay? So now let's actually solve them with bounded and unbounded. So what that means is bounded is when you're stuck in between two numbers. This was unbounded. You just kept going. There was no bound to your inequality. So we have to free up our equation. We have to distribute. And then we're going to combine like terms. So we're going to simplify before we solve. I'm going to subtract 5x from both sides. Now, I suggest when you're taking notes, that's fine. I already did the 5x. I suggest when you're taking notes, try to do the example before you watch me do it on these YouTube videos, and then watch me do it, because a lot of this is review, and see how well you can do, and then the mistakes you made will help you learn more than just watching me do this, okay? So 2x plus 14 minus 4, 5x minus 15. Combine like terms. Bring 5x to the other side to get -3. Bring 10 to the other side to now get -25. When you divide by 3, you get 25 over 3 or whatever decimal that is. And a negative divided by a negative is a positive. Well, we divided by a negative. When you divide or multiply by a negative, you need to flip the sign. Do you guys remember that? Do you remember why? Because order is different on a number line. So if you look at this number line, it goes in the order 1, 2, 3. If you look at this side of the number line, it doesn't go 1, 2, 3, it goes 3, 2, 1. So the order is flipped on the other side of the number line. So when you multiply or divide, you have to flip the sign. And just think about it logically too. If I had 2 is less than 5. Yeah, that makes sense. But if I multiply both of them by -2, that doesn't make sense. -4 isn't less than -10. -10 would actually be way less. So because the numbers flip, when they become negative, you have to flip as well. Okay, so just remember that. Flip the sign. Make a little asterisk here and say flip sign with negatives. And it's only when you multiply or divide. Okay, here we're stuck in between 2 inequalities. So we have to get rid of anything that's near x. So how do you remove -1? You add it to all sides. Like I said, pause it and try to do this on your own. And then divide all sides by 6. And you can reduce these numbers to 1/3. I'm not fond of these examples, but I'm trying to stay consistent with the book's examples so that you can look at it in the textbook as well if you want further understanding. So you're stuck in between these two numbers. Now, this is what's called bounded. You are stuck between two numbers. This was unbounded. You weren't stuck between two numbers, okay? This is unbounded. So when we say that in mathematics, we don't use numbers, okay? When we're creating a rule or a conjecture or a theorem, you use letters. And sometimes that's hard. So my suggestion is, as you're starting out, replace these letters with numbers and it might make more sense to you. This is a closed, okay, interval type because you're actually touching the numbers. And the inequality would be your variable is stuck between A and B. So this is like this. So a notation here might be like you're in between 2 and 3. You're in between 5 and 17. And how you'd graph it is I am in between A and B, and I can be A and B. Okay. Same thing here. This one's open completely because you're not actually touching a number. This wouldn't be closed or open because it has a little bit of both. So this would just be the same thing. It's saying you're in between two numbers, but you actually don't ever reach those two numbers. You're just between them. Same thing. So you could say the same thing, like, oh, I'm in between 5 and 10. So I'm not 5, but I'm 5.1. Same thing here. All these are going to be the same, except the are you equal to or not. So this one's saying you're equal to A. This one's saying you're equal to B. So these graphs are all going to look the same. It's just, do you have open or do you have closed circles? Now, open and closed circles is what we've been using just like these inequality signs. Like we said, a more sophisticated notation has been the bracket and the parentheses. So your textbook isn't going to have open and closed circles. Like I said, if you are handing in work that way, that's fine, but you have to recognize in multiple choice that you might see it like this, where you're going to have A and B, and instead of a closed circle, they're going to have a bracket. And instead of an open circle, they're going to have a parenthesis. Same thing down here, A and B, you're going to have an open circle and a closed bracket. Okay, either or, I don't mind. I'm saying whatever professor you have or textbook you have, you switch colleges, you got to be prepared to be able to remember and use and realize all of them. Bounded means there's a beginning and ending. Okay, all right, next page. There's unbounded intervals. And when we say unbounded, let's go back to our notes and say, this was unbounded. You just started somewhere and went, okay? So here it's saying I'm starting at a number going all the way to infinity. Okay? So the inequality would be you are starting at a number and you're greater than that number. So you are starting at a number and you're greater than that number. You are starting at a number and you are just simply greater than that number. You are starting at a number and you are less than that number or equal to it. You are starting at that number, and since it's saying negative infinity, you are less than it. And here, you're going from negative infinity to positive infinity, so you are all numbers, okay? You can say all real numbers, x as an element of all real numbers, however you want to write it. So the graph would look like this. I am starting at a number, and I am greater than that number. I am starting at that number, and I am greater. I am starting at that number, and I put the bracket in the direction it's going, and I'm less than that number. I'm at that number, and I am less. And when you're all real numbers, you're every number on the number line. So it's all filled in. Okay. If you were no solution, that number line would just be empty. So checking for understanding. So this is what your homework's going to look like. Write an inequality to represent each interval. Then state whether the interval is bounded or unbounded. So you're in between 3 and 5. You are equal to 5 because there's a bracket. You are not equal to 3. Okay. Now you're in between two numbers, so you're bounded. Here, you're not in between two numbers. You are starting at -4, and since it's -4 and greater, you're greater than -4, but you're not equal to. Be careful. So there's no equal to because it's not a bracket here. There's a bracket here, which doesn't make sense. It needs to be moved. That was just a typo then. Because you can't equal infinity. Okay. All right. So that means that you're unbounded because you start somewhere and you keep going. Okay. And that would mean that that was bounded and that's unbounded. So you're stuck between two numbers. You are bounded. You aren't stuck between two numbers, so you're unbounded. I am in between two numbers. Now they're both equal. I'm sorry about that. Come on, go back into focus. There you go. I'm stuck between two numbers because, or I'm sorry, equal to because of the brackets. There's no brackets here. You start at 0 and it's -infinity, so you're less than. Okay. It says inequalities involving absolute value. So now that we've talked about inequalities with just regular equations, let's talk about absolute value equations. Now this is a little bit trickier. So absolute value. Absolute value of x equals 3 means that x could have been the number 3 because on a number line, it's saying your distance is 3. Absolute value equals distance from 0 on a number line. Okay, so 3, 1, 2, 3. If your distance is 3, it could have been the number 3. Or your distance is 3 this way, so you could have been the number -3. Okay, here, if your distance is 2, what could x have been to get a distance of 2? Okay, so you're saying if you wanted a distance of 2, you wanted to be the number 2. If you wanted a distance of 2, you could have been the number -2. Therefore, x would have had to have been -3, and therefore x would have had to been -7 to make that a distance of 2. So you're always going to have two equations because there's two directions for distance. So sometimes we think about it too much when we get another number in there. No, 2, -2, 3, -3. Same thing here. What does this mean? We're talking about inequalities now. I want a distance of less than 2. So if you think about a number line, you want a distance less than 2. So you want to be less than the number 2. You also want a distance less than -2. Well, if you have a distance less than -2, you could be the numbers -1, okay? And that number is actually greater than -2. So because the direction flips, your inequality will flip. So you'll set up two inequalities. You'll write it like you normally do because that makes sense. Less than 2 could be the number 1 or 1/2. And you want to be less than 2, so your number is actually greater than -2. So your answer is going to be 7 and 3. Okay. You can leave it like this, or you can notate it like we did up here. I'm fine either way. Here, you have to get the absolute value bars by themselves because if I told you what's the distance, you'd say 13, but it's not because there's a 6 in the way. Your distance is actually 7. So if you want a distance greater than 7, you'd want like the number 7, 8, 9, 10. Those numbers are greater than 7. But if you want a distance of I'll show you. If you wanted a distance greater than -7, or a distance greater than 7, you'd be the numbers -8, which are actually less than. So once again, you write it like you normally would, then you flip the sign. Wait till you get the absolute value bars by themselves, then write to equation where the bars are removed. I cannot tell you how many times students write this and then start working off of this. Don't do that. Once you've gotten this, then rewrite to equations without the absolute value bars and then solve, because you're actually solving for two different situations because it's two different directions. And that's it. If it asks you to graph, you need to graph. Okay. And that's it. Your homework is in the textbook always, except for the last few assignments at the end of the semester. And if you have questions, email me. And it's in your syllabus. And answers are in the back of the book and posted in your files.